Hello. I know it's been a long day. Thank you for hanging out with me today. If you haven't figured it out yet, I am Jeremy Clark, and I am here to talk about Lambda expressions in C#. The reason I talk about this is the same reason I talk about a lot of things, and that's because it was something that was difficult for me to learn and then became very important to me as a developer. So basically what I want to do is remove the mystery around the crazy syntax with Lambda expressions and see how they really fit in with LINQ, language integrated query, which is the most awesome thing ever to be added to C#. And it's not just querying databases. I use LINQ for in-memory objects all the time. And we'll see an example of that. Just as a warning, I'm going to be spending most of my time in code. Not a big fan of slides unless they are water slides, and that's later tonight. So if that sounds good, then let's go ahead and get started. I want to start out just by talking about kind of where we see Lambda expressions. There's kind of a lot of places we commonly see them. Like I mentioned, LINQ, language integrated query, specifically in the method syntax. And as we'll see, the method syntax kind of gives us a lot of flexibility that the query syntax doesn't quite offer, and so I kind of prefer it for a lot of operations. And the thing is, when we look at this example here, we can kind of see, okay, well, I can kind of tell what's going on. So I'm comparing a first name property to something that's in a text box. And so this is going to return true or false, whether it's equal or not. And it's in a filter where, okay, so this is some kind of filter, but what is that P and where does it come from? So I kind of have a general idea of what this is doing, but the specifics are kind of outside of my grasp. Another place we see them is func and action. Func and action are built-in delegate types in .NET, which can be extremely useful to us. And what we'll find is that the way that I most commonly use Lambda expressions is as an anonymous delegate. If you don't know what that is, that's perfectly okay, because we're going to find that out as we go along. So func and action are built-in delegates that kind of give us some generic types that we can work with. And we look at this one and we say, okay, I can figure out what this is doing. It's taking the last name property and uppercasing it. That's not too complicated, but again, what is this P and where does it come from? I don't know. Another place we can use them is with callbacks and event handlers. So we're used to hooking up event handlers, and what we can do is we can use Lambda expressions for those as well. And so here we have kind of a standard event handler, which usually has a sender object and then some kind of event args. And in this case, it's assigning the result property to a list box. So there's kind of a lot of different things that we can do and where we see Lambda expressions. And that's why it's important to understand them. It's also very important in the task world. If you've ever had to deal with asynchronous programming with task, you will see Lambda expressions everywhere. It's not required that you use them. You can use a different syntax. But the problem is every single example you find online will use a Lambda expression. So let's kind of take a look at the anatomy of a Lambda expression. There's just 3 parts to it. There's a set of parameters. That could be 0, 1, or more parameters. Then there's that cool fat arrow known as the goes to operator. And that is in between the parameters and the rest of the Lambda expression, which in this case could be either an expression or a statement or set of statements. When we look at an expression Lambda, this is something that returns a value. So again, here I can see, okay, I'm comparing the first name property to John. That's going to return true or false. So that's actually returning a value. A statement Lambda does not return a value. It performs some kind of work. So in this case, I'm assigning something to a list box and then outputting hello to the console. So I'm either returning a value or performing some type of action, and those are the 2 types of Lambda expressions that we have. Now when we look at these and we see the parameters, in this first case person, then the goes to operator, and then the body of the Lambda, this actually looks pretty readable. And it's too readable to be a real Lambda expression. Now, the reason why Lambda expressions are so unreadable when you first approach them is because they were designed to be very compact. They came into the language the same time as language integrated query, which again is one of the most awesome things. And the thing about that is we end up passing methods as parameters to other methods. And so the language designer said, well, let's come up with a really, really compact syntax that we can use for this so that we don't have these crazy parameter structures for our methods. So there's a lot of syntactic sugar and some conventions involved. One of the conventions is it's very common to use a single character for the parameter names. So this is not a requirement. It's just something that most people do, again, kind of aiming for that short syntax. As far as this syntactic sugar that the Lambda expressions give us, there's several of them that make them difficult to approach. The first one is called parameter type inference. If nothing else, you should write down parameter type inference, because if you say it in front of your boss, you sound really smart. But what this means is that if the compiler can figure out the types of my parameters, I don't have to type them in. So here, again, this could be a signature for an event handler. So I might have a sender and some type of event args. But I don't have to tell the compiler what they are. It's going to say, oh, I know what this is based on context. So I can just put my parameter names, S and E in this case. Another thing about Lambda expressions is if we only have one parameter, the parentheses around the parameters are optional. And this is extremely common, especially in LINQ, because a lot of the LINQ methods just take one parameter. You usually don't see parentheses in that case. Another thing is that if we have a single statement, we don't need curly braces around it. And even better, if we have a single expression, something that returns a value, we don't need the curly braces, and we don't even need the return keyword, right? So these are designed to be very, very, very compact, and we'll see this in code as we go. Now, there is one last structure which I'm kind of seeing more commonly in various frameworks that I've been working with, and that is it's possible to have Lambda expressions that take no parameters. And so if you just see a set of empty parentheses, what that means is this is just a method that takes no parameters. So this is the basic anatomy of a Lambda expression, and that's all the slides I have for now. Is that okay with everybody? Can I get a woohoo? Oh yeah, I know, it's late in the day, way too late for a woohoo. So for those of you who have seen my previous talks, you know that I'm going to wow you with some amazing UI. And it's no different today. So let me run this application that we'll be looking at so we can see what we have. Okay, so let's run this. And you can see we've got this really cool set of checkboxes and radio buttons on the right. There's a, or on the left, I should say. There's a refresh button down here, which currently doesn't do anything. And I've got this list box, which is hooked up so that, well, is actually not hooked up to anything at the moment. That's the first thing we're going to do. In the project itself, okay, here's the challenging part where I see if my doomy thing is going to work. Feeling brave or foolish? That's not too bad. So if you see at the top, I have a people viewer project. That's a WPF application that we're going to be putting our code in today. The second one there, peopleviewer.library, that's going to be the API that we're consuming. And then because we're focusing on Lambda expressions, I'm going to be doing some things I don't normally do, like putting code in the code behind of my form. So if you want to see how I would build this application in real life, you can look at that bottom project, peopleviewer.mvvm, and that just uses the MVVM design pattern, so you can get an idea of how I would do this for a more production environment, but it doesn't quite demonstrate the capabilities of Lambda expressions the same way. Okay, that was not too bad for the zoomer. Let's take a look at the API that we will be consuming. Now what I have here is something that is using what's known as the event asynchronous pattern. And this was a common pattern, especially before Task came out, but you'll still see it around in a lot of code. The idea behind this is that to kick off an asynchronous process, I call a method. In this case, getPeopleAsync. So that will kick off an asynchronous process. And then once that process is done, it will fire an event. So I can hook up my code to the event handler, and I'll get notified when this asynchronous thing is done. And in this case, what we're doing is we're getting a collection of person objects, and we have a custom event args, which we can see down here at the bottom of the screen. And it has a result property, so I can look at e.result, and it'll be a collection of person objects that I can then stick into my UI. So these are the things that we will be dealing with. So to do this, basically, I just have to hook up an event handler and call that asynchronous method. And like I mentioned, I'm going to do that here in the code behind. So the first thing I'm going to do is new up an instance of this repository object. So we'll say var repository equals new people repository. And then we'll say repository.getPeopleAsync, which is the asynchronous method that I want to call. Now I also want to hook up an event handler to this to get notified of when I'm done. If you ever have to do this yourself, something very important, hook up the event handler before you call the asynchronous method. The reason for that is it's possible that this method will run very, 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 very fast, and that event could fire technically before you're hooked up to it. So I want to hook up the event handler before kicking off the async method. I am a lazy developer, so I'm going to let Visual Studio help me out. I'm just going to say plus equals and hit tab. It says, hey, it looks like you're trying to create an event handler. Do you want to do this? Yes, please. Do you want to call it that? Sure, why not? And we can see it stubbed out an event handler method, an event handler for me down here, complete with the custom getPeopleCompleted event args, which have the result that we can use. Now, I love Visual Studio shortcuts, and I love how it does all this stuff for me. Who here is a lazy developer, out of curiosity? Okay, real lazy developers don't raise their hands, so I kind of know who the real lazy developers are now. But like I said, we have that result property, which is a collection of person objects, so I can just assign that to my list box. So I have a list box called person list box, and I'll set its item source equal to e.result. And again, if I hover over e.result, we see that's an IEnumerable of person. So that's a collection of person objects. And this is all the code that I need to write. So if I run right now, what we'll see magically, when I click the button, data. Data. Yeah, no, stop. Too late. Had your chance. So again, not real exciting, right? It's kind of basic event handler code that we might be used to doing. And I just kind of want to point out some behavior now. If I click on one of my items, such as Dylan Hunt, we can see it's selected in the top left there, the selected item. If I click the refresh button, that selection goes away. Now, it's not really surprising that it does that if we think about what's happening, because every time I click the button and this method returns, I'm going to take that result and assign it to the list box again. The list box doesn't know that I keep assigning the same data to it over and over and over again. So it's just going to say, okay, I'm discarding what I have, and I'm getting what you're giving me. And that includes forgetting what the selected item was. So the behavior right now makes sense. The reason I'm pointing that out is we might fix that in a little. Now what we have here is an event handler. And an event handler is a special kind of delegate. Now, what we have right now is known as a named delegate. And when you talk about delegates, terminology gets a little hairy, so I'm not going to go too deep into that. A named delegate is just a method that has a name. In this case, it's called repository_getPeopleCompleted. But I can turn this named delegate into an anonymous delegate very easily. And I do that by inlining the code. So that's the first thing that I'm going to do. So I'm going to copy the parameters and the method body. I'm going to come up here, and instead of doing this assignment up here, I'm going to type the delegate keyword and then paste. And what I've just done is inline that code. Now you'll see I've got some red squigglies here. Visual Studio's not happy with me. And that's because I already have something called sender that's in scope here. So I'm going to change this variable name here to repo sender. And then the same thing here with the E. I'm just going to change this to repo args. And we'll change this guy here to. So now I have an anonymous delegate. What's an anonymous delegate? The technical definition is it's a delegate without a name. That's useful, isn't it? Yeah, it's basically inline code is what we have. So I can come down to this separate named method that we have here and comment it out, which is what I'm going to do. Magic keyboard shortcut, Control-K-C to comment out a block of code. And when I run the application, we'll see we have the same behavior we had before. So we'll click on the button, And again, I can select an item, in this case, Turanga Lila. Click it again, the selection goes away. Now, I mentioned that Lambda expressions can be used as anonymous delegates. Well, I currently have an anonymous delegate. That kind of implies I can turn this into a Lambda expression. Okay, you ready for this? This is very complicated. Okay, pay very careful attention. Okay, what I'm going to do is I'm going to take the delegate keyword and delete it. And then in between the parameters and the method body, I'm going to add that fat arrow that goes to operator. Ta-da, that's a Lambda expression. Here, I'll do it again. Okay, so delete the delegate keyword, add the greater than, or the equal greater than sign. That's it. We have a Lambda expression. Again, this is way too readable for the way we normally see Lambda expressions. Let's go ahead and just kind of take advantage of some of that syntactic sugar. So again, based on parameter type inference, I don't need to put the types of these parameters up here. Now, Visual Studio still knows what it is. If I hover over repo args, it still says this is a get people completed, is it? Get people completed event args, right? So it's still strongly typed. Just the compiler knows what can be in there. And the reason it knows that is based on what we're assigning it to. So we're assigning it to this event, so that means it has to have this particular signature. If I were to try to add a third parameter, like test, for example, then the whole thing is going to start screaming at me. Yeah, that's fun. Because, again, I'm allowed to assign something with 2 parameters, and it knows what those parameters are. And if we run this, again, we'll see we have exactly the same behavior. So we'll click on an item, select Turanga Lila again, refresh, the selection goes. And in this case, why not? We could actually get rid of the curly braces since we've only got one line of code in here, just like that. And this is perfectly valid. I won't shorten the names of the parameters in this case. We'll save that for later. I'm actually going to put the curly braces back in because I'm going to be adding a little bit more code here. So now I have a Lambda expression. Big deal, right? Should I care? Well, hopefully we understand this syntax a little bit better. But there's actually some kind of cool features about Lambda expressions that we can take advantage of. Now, I want to take care of this thing where I'm losing the selected item each time I click refresh. So I'm thinking about, okay, how do I do this? Okay, well, before I refresh the items, I'll go ahead and pull out whichever one is selected from the list box. Okay, and then after refreshing the list box, I'll just loop through those items and see if I can find one to match. If I find one, I'll say, okay, that is now the selected item. Okay, it's just kind of basic step-by-step code for that. So at the top of the method, oops, there we go. Yeah. I'll create a person object named selectedPerson, and we'll set it equal to person ListBox.SelectedItem, and I'll say as person. So the items in a WPF list box are not strongly typed, so I'm going to go ahead and coerce this to be the shape of a person object. Now, what I like about as is that if it can't do that, because there's something else in the list box, it's just going to return a null. It's not going to throw an exception, it'll just return null. And so in this case, I'm saying it's perfectly acceptable for selected person to be null, right? Either there's no selection or there's something else in the list that we don't understand. Okay, so that saves off the current item. And then in here, in the body of my Lambda expression, this is where I'm assigning the new collection to our list box. So after this, I'm just going to do a little bit of code. So I'll say, first of all, let's check to see if selected person is not null. Because if it's null, I don't want to go through any of this process. Now, if it's not null, then we'll go ahead and do a for each on the persons in our list box. So person ListBox.Items. Whoa. And then what I'm going to do is see if I can find a matching item. So I'll say if the person in our list box's ID property is equal to the selected person's ID property, then I found something that matches. And so I'll go ahead and set the person list box selected item to our current person object. Now, oh, because that's an assignment. That's not a method. It's going to be an interesting day if I can't tell the difference between a property and a method. So I kind of don't like this nested if for each stuff, but it's going to work. And if I have time, we'll fix this. We'll turn it into something a little more readable later once we're more comfortable with LINQ. But for now, let's see if this works. OK, so I click on the button. I select Dylan Hunt. I click on the button again. And hey, Dylan Hunt is still selected. Woohoo, success. Isn't nobody impressed by that? OK, there's something. Well, there's something that you all missed, apparently. Because I'm currently using a variable that's out of scope. Wait, what? Yeah, OK, let's set some breakpoints and take a look at what I mean by that. I'm going to set a breakpoint here at the top of the method. I'm going to set a breakpoint here in the body of the Lambda expression. And let's just walk through this code. I'll click the button, and I'll just kind of skip through these breakpoints since we don't have a selection the first time around. I'll click on Dylan Hunt and click refresh again. OK, so as we step through this, we'll see, OK, selected person. I won't zoom in. It says Dylan Hunt. It's not null. OK, so the selected person gets set. And then we step. And notice how this whole block of code is highlighted? This is doing the assignment of the Lambda expression to the event. So this is connecting the event handler, not actually running the body of this. That runs after the event fires. OK, and so if we step here, then we call that asynchronous method, and then we get to the bottom of the method. Selected person is a method level variable. What normally happens when you hit that bottom curly brace? It's gone, right? It's eligible for garbage collection. OK, so what's happening? OK, let me just run. So we hit that second breakpoint because the event has fired in the meantime. And if we step down to see if selected person is valid, it still says Dylan Hunt. OK, great. And that's how we maintain our selection. This is using something that the rest of the world calls a closure. Since Microsoft built this, it's not called a closure. It's called a captured variable. So it's the same thing as a closure in other languages, but we call it a captured variable. Personally, I think captured variable is a much more descriptive name of what we're doing. So basically, inside my Lambda expression, I'm able to use anything that's in scope when I'm doing that assignment. Since that assignment is happening inside this method, that method level variable's in scope, so I can use it. And what that means is it will hang on to a reference to it. So this allows us to scope our variables at the right level. Because let's think about what would happen if I was still using this separate method that I have commented out at the bottom. Well, this method needs access to the selected person object, and I need to set it in the prior method. That means I need a class level variable in order for that to work. It also means technically any of my other methods can access that class level variable and change it. So that's kind of a bigger scope than I really want for that. With the captured variable, I can say, you know what? The selected person is only visible inside this method, and you know what? The Lambda expression can use it as well. So that's really cool. Now, obviously, we can go too far with this if we keep large objects in memory and we don't make them eligible for garbage collection. We can get into some trouble. But generally, for the things we're looking at, it's OK. Now, there's something to be aware of when we're talking about captured variables, and that is the value of the captured variable is the value at the time it's used, not the value at the time it's captured. Let me show you what I mean by that. So down here at the bottom of my method, I'm going to set selected person equal to null. OK, and let's go ahead and just run this again. OK, so we'll click again. We'll kind of skip through this first time since nothing's selected. I'll select John Koenig. And as I step through this code, OK, so selected person says John Koenig. You can trust me on that. We do the assignment. So at the time of assignment, when we're capturing the variable, it has a value. Then we set selected person to null, and the method continues to run. Now, if I run from here, once we get back to the body of the Lambda expression, selected person is in fact null. Okay, so it's the value at the time you use it, not the value at the time it's captured. It's generally not a problem. The only place I've seen it be a problem is if you try to capture the indexer of a for loop. And if you want to see how cool that is, I have an article on my blog that you can find if you follow the links to this talk on my website. And so if we run, we'll see that this, the selected item is empty here, as we would expect. Okay, so let's go ahead and just comment out that block of code and get rid of these. Let's just rerun and see if this still works the same. So refresh, click Laura Roslin, refresh again, still selected. Okay, so we're back to our state where everything's working. Now, I do have some other things I would like to do with this list. We can see these checkboxes here for filters, and I also have some radio buttons that I want to use for sorting this. And I'm just dealing with an in-memory list. Again, I'm not doing like SQL entity framework queries or anything like that. This is just a collection I have in memory. And I can use LINQ, language integrated query, in order to handle these buttons. And we can do that using Lambda expressions. But first, we kind of have to figure out what are the things that we can do. Now, when we're looking at this result property, we see it's an IEnumerable of person. IEnumerable of T is the magical thing that makes this link to objects possible. So what I'm going to do is I'm going to open up help and take a look at IEnumerable of T. Now, if you've never done this, you really need to do this yourself. Because in addition to the regular methods that we have, there's extension methods. And these extension methods are LINQ. These are all the methods that give us access to LINQ. So there's a lot of them, and they're really interesting. We have aggregates, we have averages, so there's some averages. There's a lot of them here. There's a copy, copy to, descendant nodes, descendants, element at, first or default, which I'm actually going to use a little bit later. But the thing that I'm looking for, there's group by and select and all kinds of stuff, is way down at the bottom. Not at the very bottom, but it's pretty close. Did I say there were a lot of methods? Go through this list. There's a lot of useful stuff in here. And I'm, too far. I actually want to get to this one, which is where. Okay, click on where. And I'm going to zoom in on this guy. And woo! Be tricky. Okay, don't move. Now, the first problem is trying to interpret what this thing means. Because this is an extension method. And what that means is that if we notice the first parameter where it says this is an IEnumerable of T source. So in our case, T source, our type, is a person object. So wherever you see T source in here, think person. Okay, so this can work on an IEnumerable of person. When we have this, that means we can use kind of a funky syntax where we put this in the front rather than as a parameter. Unfortunately, I don't have time to go into those details, but I have a short video on my website that you can look at for that. The return type for this where is IEnumerable of T source. Okay, again, IEnumerable of person in our case. So this is a method that takes an IEnumerable of person and returns an IEnumerable of person. Okay, that sounds pretty good. Now, since it's a where, I'm going to assume that there's some kind of a filter in there, right? Because I've done databases, and that where statement is how we filter things. Well, that's what this second parameter that we have here is. And this is a func of T source bool. So again, T source is person, so this is a func person bool. Now we have to say, okay, what is func? Well, like I mentioned, func is a built-in delegate type, and that represents a specific method signature. So I'm just going to flip over to func of result, and we'll look at him. Whoop. Oh, wow, almost had it. Okay, don't touch it. So what this is saying is that I have a delegate that takes a parameter, that first T, that's our incoming type, and then the second one, the second generic type parameter, is the type that's coming out of this. So a func returns a value, and in this case we're taking one parameter And since it's a func of person bool, means first parameter is what's coming in. So a person is coming in. Second one is what's going out. A bool is going out. So a func of person bool, I need to create a delegate that takes a person as a parameter and returns a true-false value. Now when I say it like that, it sounds pretty doable. Now the thing about func is basically wherever I see func in an API somewhere, I treat it as a big flashing sign that says, put your Lambda expression here. Because it's really designed for us to go ahead and put our anonymous delegate in here as a Lambda expression. So let's go ahead and do this. I'm going to create another method that I can use for filtering. And since our where takes an IEnumerable and returns an IEnumerable, I'll go ahead and kind of do that same format. So I'll do a private IEnumerable of person, and we'll call this add filters, since I want to filter things. And it takes an IEnumerable of person as a parameter, which we'll call people. And then we need to return an IEnumerable. So I'm just going to return the same thing that's coming in, just give us a little default case. Now I have two different filters on here. I'm going to start with one that has to do with the first name property. So there's a little text box, and it's actually the given name in this case that I want to look at. So what I can say is if the given name name filter checkbox is checked, then I'm going to say people equals people.where. And what I've done is since that first parameter on where had a this on it, I can move it and stick it actually in front of the where. So this people.where, the people is the first parameter. And if we look at Visual Studio's telling us, it's saying, okay, well, I see you have that first parameter. Now I need that func of person bool. And you can see it's very helpful. It filled in those generic types for us. So we know I need a func of person bool as a predicate. So let's just be a little bit verbose since we're still kind of new to this Lambda expression thing. So I'll say person goes to person dot given name. Oh, given name equals our name our text. Oh, there we go. Name text box dot text. Boy, that got a little long. Beep. Semicolon. So I'm saying if the given name of the person matches whatever values in the checkbox, then in the text box, then that's the criteria I'm using to filter this list. Okay. You think this is going to work? Maybe? Well, not yet, because I'm not actually calling this add filters method. I say that out loud because I usually forget to do that when I'm doing this on stage. Now I'm going to kind of kludge this code up a little bit. So up here inside my Lambda expression, again, this repo args.result, that's the collection of person objects I'm assigning to the list box. I'm going to intercept that and say add filters around that. And since add filters takes an IEnumerable and returns an IEnumerable, my list box doesn't know any different. So let's go ahead and just run this and see what happens. So we'll click on the button. We'll go ahead and click on John Koenig. I'll click on the checkbox to filter where the first name is John. And now I can see I have a filter. That's pretty cool. Yeah, that was easy, right? I just added filtering to my in-memory list. Now, of course, this Lambda expression is a little verbose at this point, so let's go ahead and fix that. Again, with parameter type inference, I can get rid of the type. I can go ahead and change this person to just a P for the name. And when I pick those one character parameter names, it's based on the type. So if I'm dealing with a person, I'll use a P. If I'm dealing with a catalog, I'll do a C. And then I can get rid of these parentheses as well, since I only have one parameter. So this is what we were used to seeing when we walk up to one of these Lambda expressions with a where. Now, I do have another filter which is based on dates, and I've got a little bit of something I don't want to type. So I'm going to copy and paste this into. So up here at the top, basically what I'm going to do is retrieve the values from the text boxes that I have on the screen and turn them into integers that represent years, because I'm going to say between this year and that year is really what I'm looking for. Now, the great thing about LINQ is that we can kind of combine these methods together. So I'll say if the date filter checkbox is checked, then people equals people.where, and I'll just say p goes to p.startDate.year is greater than or equal to the start year property that, again, we pulled out of our UI. And I can chain these together. So I can say .where p goes to p.startDate.year is less than or equal to the end year. Okay, that line's getting a little long. I'll come back to that in a second. Let's see if this actually works. Okay, so there's my refresh. I'm just going to go ahead and pick John Crichton. Why not? So let's try the filter first, or the dates first. Okay, so I filter by year. Okay, so that just filtered out everything. So it's between 1985 and 2000. Okay, and then I can filter John for the names. I can actually filter both. It will do both the date and the name filter. So we can say .where as many times as we'd like, and it'll go ahead and take care of it for us, which is really cool. One thing about LINQ is in the situation, especially with LINQ to objects, this is lazy evaluated. So when I do this .where and put in my conditional, it's not actually changing, it's not actually iterating the collection or changing anything. It's only when I actually go through that IEnumerable that those filters are applied. So it's not actually filtered until I use it. In this case, that's when I assign it to the list box and it iterates through it to put them in the list. Okay, now I don't really like this long line. And we're used to this now, but when this first came out, I was like, something's not right here, because before this dot, I can put in a line break. And I can actually put in a line break here too. The first time I saw this, it really, really bothered me. And then someone's like, you know what, Jeremy, C# is not a white space sensitive language. This should not really worry you. I'm like, well, this isn't like the difference between a space or a tab. This is where there was no white space now has white space. So the first time I saw this, it really bothered me, but this was many years ago now that this first came out. So I'm used to this. And so it's really nice because it allows us to kind of format our code and make it more readable. Now, another thing I could have done here is just had one where statement and put, double ampersand, put the conditional in there, but I wanted to show you this syntax as well. So what we're seeing is here, if both checkboxes are checked, there's actually 3 where statements that are impacting this one collection of objects. That's pretty cool. I can do that as much as I want. Wow. Does anyone like LINQ to objects yet? It's great. I also have these sort buttons, which I would like to do here. Now, before I look at any sorting, I just want to point out these are not in any particular order. It's just the order that they were in the collection when it came. So if we look at the given name, if we look at the family name, that doesn't really matter. They're just kind of in no particular order whatsoever. So I want to filter by the family name, by the given name, by the start date, and by the rating. So let's see if I can find a LINQ method that will help me with that. So let's go back to our list of really cool methods on IEnumerable. And I'm going to scroll up to a great one called order by. Find it? Did I tell you there were a lot of methods in this list? It is so cool. Go through this list. You will have all kinds of. Okay, and then I'm going to try to happily. Oh, almost. Close enough. Now this looks very similar to the where method that we saw. So again, we have the this on the first parameter, so it takes an IEnumerable of person in our case. Notice the return type on this is a little different. This is an I-ordered enumerable. So it's going to have a concept of I'm in a particular order. So it returns an I-ordered enumerable. And let's look at the func. Okay, so we have something that's called a key selector in this case. So this is a func of tsource tkey. And again, tsource is person, so a func of person something. Tkey is any type that implements the I-comparable interface or the I-comparable interface, depending on where you're from. So nothing really? It is late in the day. Okay, so it has to implement either iComparable or iComparable. And the good news is all of the built-in types in .NET do. And that's just, that interface just says, I have a concept of this comes before that. So strings have a concept of alphabetical order. Integers have a concept of, greater than, less than. So dates, before and after. So with that, that means that we can basically use anything that's built in, and then if we have our own custom types, we can implement that interface so we can tell the system how we want to order things. So what I'm going to do is just create another method here that can be used for ordering. So we'll say private IOrdered enumerable, since that's what comes out. We'll call this add sort. Takes an IEnumerable of person on the inside, which we'll call people. And I would like to just say return people. Because, kind of the default state, just send out what you got in. But notice the type is different. So I can't just return people because it's not an IOrdered enumerable. So let me go ahead and just add a default sorting for this. And I'll sort on the given name. So I can say return people.orderBy. And then again, I'll let Visual Studio tell me what I need. I need a func of person T key. And again, person, I'll just say P, that's my incoming type. And I need to return something that implements iComparable. So I can say P.familyName. And that'll just be my default sorting. Now, I do need to call this method. So again, this code is not something I would normally write, but I'm just going to nest this again. So I'm going to say add sort up here and wrap this add filters. So what we're doing is we're getting the collection from our API, we're running it through our add filters to filter it, and then we're running it through our add sort method to sort it. And then we're assigning it to our list box. And so if we run now, what we'll see is they are now in order by family name. And it's actually going down, so we can see it goes Crichton, Gampu, Hunt, Koenig, Lister, Montana, Roslyn, Sheridan, and actually Turanga is the family name for the last one. Okay, that's cool. Let's do some radio buttons. So let's see. So we'll say if family name sort button is checked, then return people.orderBy. P goes to p.familyname. If given name sort button is checked, whoa, it is. Return people.orderBy. P goes to p.givenname. And again, strings both implement iComparable, so that can sort. If date sort button is checked, we'll return people.orderBy. P goes to .startDate. Date has a concept of order. And if rating filter, rating sort button is checked, return people.orderBy. He goes to p dot. So I can just add these and it will sort based on whichever radio button's selected. Now I kind of still need that default thing down at the bottom so Visual Studio doesn't complain at me, but this will hit all of my radio buttons that I have in my UI. So let's go ahead and check this, and so it's sorted by family name by default. I can check given name. I do have to click the refresh button on this application. Now it's sorted by given name. So Dante, Dave, Dylan, Isaac, John, Laura, and Leela. Then I can go by start date. I can see 1975 at the top, 2003 at the bottom. And the colors are actually grouped by decade. So I can at least tell they're grouped by decade based on the way the colors are all together. And then if I go by rating, now I have 4 out of 10 stars at the top, 9 out of 10 at the bottom. I actually want the highest one at the top. So instead of using order by, I'm going to use its sibling method, which is order by descending. So we can flip the order on this. So if I do order by descending, now when we do rating, we'll see we've got, not do that right? Oh, I did it on the wrong one. You know what? Thank you for still being awake. Really late in the day, isn't it? They took away the coffee. Yes, I'll be glad to share my Diet Coke. Okay, so if I put it on the correct one and sort by rating, now we see 9 out of 10 stars at the top, 4 out of 10 on the bottom. Now there is something about this given name, though, is that I have 3 Johns. So I'm thinking, you know, I want to subsort by the family name. Okay, that sounds easy enough. Well, we did this really cool thing where we stacked our where statements, right? So let's just do that. So order by given name dot order by p goes to p dot family name. Okay, that sounds reasonable. Wouldn't it be great if code was reasonable? So we click on it and we see there's our sort by family name. Click on given name, and the sorting doesn't change. Did I break it? Well, let's see. Oh no, start date still works. Rating still works. Yeah, I won't tell you how long it took me to figure this out the first time. But order by is a destructive sort. So basically what I'm doing here is I'm ordering it by the given name and saying, no, 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 just ignore all that, order by the family name. Now, you're probably going to spend a lot of time going through that big list of methods on IEnumerable to try to figure out, okay, which one do I need to use? And the answer is, it's not any method on IEnumerable. Why? Because we're now using an I-ordered enumerable, which has all the same LINQ methods available to it, plus a couple extras. I'm going to save you a lot of time searching and saying, you know what, for secondary and tertiary sorts, do dot then by. That's going to save yourself a lot of time. And you can see there's also a then by descending, so we can choose the order that we want to go in. So now if we do this, we'll see we can be sorted by family name, we can be sorted by given name, which actually works. And if we look at the Johns, we see we've got John Crichton, then John Koenig, then John Sheridan. So it is doing that subsort. And our other ones are still working as well. And these can be combined with our filters. So we can actually filter on whatever we want. Now something I just want to point out, since we are dealing with nulls, notice I have Dave Lister selected right now. If I filter, Dave Lister's no longer on the list. So you can see my selected item went away, but because of the null checks we have in there, we're saying if you can't find it, that's okay. But we can see we've got John Sheridan and John Crichton. If I change the sorting by family name, then they flip direction, right? So all of this stuff works together. That's really cool. And if I do select something that remains in the list, then that selection will be maintained with the way that we have our code set up. Now, like I mentioned, I'm not a huge fan of this code that we have to do the selection, right? So we've got this if selected person not equal to null, then we for each, then we have another if. The thing that I really don't like about that is the thing we're trying to do, set the selected item, is way down here nested 3 levels deep. So the thing I'm actually doing is way down here. I have to go through this and figure it out. The other thing is that I have to think about how this will be impacted by other things. So let's say that I end up with data that has 2 people with the same ID in it. Which one will be selected? Will it be the first one or the second one, last one? But you have to think about it, right? What happens if it can't find a match? What does selected item equal then? Well, in this case, selected item would be unchanged, right? If we don't hit that bottom if statement, which means it would have whatever the previous value is. Well, what's its previous value? Well, again, we know since we're resetting the data, it's null in this case. But we have to stop and think about it. So I would like to make this a little more obvious what this value is going to be in various circumstances. So I'm going to change this code by using a little more LINQ. And let's do Control-K-C to comment out this block of code. And I'm going to use a method called first or default, which is one that I really love. So what do I want to do? Well, I want to set the person ListBox item selected item. So I'm going to make that upfront person ListBox.selected item equals. Right now, I wish it was not quite as complicated as it is, but what we'll do is we'll say, okay, so we're going to set the selected item based on something that's in this collection. Okay, so let's say person ListBox.Items And then what I need to do is, like I mentioned, the items in a WPF list box don't have a strong type in them. So I want to coerce them into person objects. So I'm going to use a method called ofType. And I can say, OK, so go through the items that are in this list box and give me everything that is of type person. Now, in this case, that's all we have in there, so it's going to give me everything. But now my list is strongly typed. And so then from there, I can just add another dot and say, well, I'm going to use first or default in this case. And we'll go into the details of that in a minute. Now, first or default has a couple of overloads. I actually want to use the second one. Now, let's look at the parameter on this. The parameter is a func_of_person bool. That's the same thing I had in a where statement. So that means I just need to craft a Lambda expression that, again, takes a person as a parameter and returns a true-false value. I can do that pretty easily. So again, I'll just say p goes to p.id, and then we'll compare it to our selected person. Again, we still got that one floating around, .id. And then I can finish off that statement. And now in running this, we'll see we have the same behavior we had before. So if, OK, we almost have the same behavior we had before because I forgot about the null. Now I could add an if not null at the top of this, but I'd rather use the cool Elvis operator right here. So if selected person is null, you know what? Stop. That's basically what that is saying. So in that case, again, first time through, nothing's selected. So selected person is null. So I can select Isaac Gampu, click on refresh, Isaac Gampu is still selected. So we maintain that same functionality. But again, what I like about this is what I'm trying to do, set the selected item is right up front. That tells me what my goal is. The other thing I like about this is if we understand the behavior of the first or default method, I know what to expect. OK, so first implies that if it finds more than one, it's going to pick the first item it comes to. OK? There's also a last if you want the last one. There's also an element at if you want to pick one in the middle. So the first tells me if it finds more than one item, give me the first one. Now what the or default says is if you don't find anything, return me the default for this type. Since we're dealing with a person, which is a reference type, the default will be null. So it's saying if you can't find it, give me a null. Now there is a method just called first. And in that case, if it finds one item, it will return it. If it finds more than one, it will return the first one. If it finds 0 items, it will throw an exception. Okay, so again, that's behavior that we can expect. Another one that I like, first or default, there's also the, yeah, we'll just stick with those. So again, based on this, now I don't have to think, OK, what happens if there's more than one? Well, I get the first one. What happens if there's nothing? Well, I get a default, which is null in this case, which I'm perfectly prepared to deal with. So to me, this is much more approachable. Now again, we do have to be comfortable with Lambda expressions in order to do this. And in my world, that is perfectly OK. So wow, I can't believe I actually made it through all my code. Was I talking really fast? Yeah, I wanted to. Yes, I was, I know. But I actually do want to talk a little bit about LINQ because, again, LINQ is awesome. It's one of the best things that was added in C#. And we have 2 ways of doing it. We have a query syntax, which looks a lot like a SQL query for those of us who have done SQL queries for many years. And then we also have what the method syntax that's also known as the fluent syntax. And this is where we dot the methods together. Now, this is the one that I use most of the time in my coding. And that's because when we're looking at the query syntax, we have a limited number of operators we can deal with. You know, we do have a where, we do have a group by, we do have an order by, and things like that. So kind of the basic functionality is there. But there's nothing that says first or default that I can use in that query syntax. Now you can still use it. What you would do is you would take your entire query, wrap it in parentheses, and say dot first or default. Perfectly able to do that. But I found that once you start mixing the syntaxes, it gets a little confusing for the developer to really understand what's going on. So because of all of those extension methods that are available when we use this fluent syntax, that's what I normally lean toward. Now, I just kind of want to do a quick review of how we did this where method and just kind of parse this one more time. So again, this is the method signature that we had. And again, what we're dealing with is IEnumerable. These methods are all things that work, that in this case of where, it takes an IEnumerable and returns an IEnumerable. And again, because we have the generic type parameters, in our case, since we're dealing with person objects, we have an IEnumerable of person. The this, again, if you're not real comfortable with how extension methods work, I'd recommend going to my website. You can follow the links for this particular talk, and you'll find my little short 5-minute video that talks about Lambda expression. The this basically means that in addition to the normal static method syntax that we would use, we can use kind of this little syntax that makes it easier to read, where this first parameter now goes in front of the where instead of in the parentheses. And again, when we're dealing with func, this is our delegate that we need to assign. And most most LINQ methods will have a func of some kind in them. And today we saw a func of person bool twice, and we also saw a func of person.tkey, comma tkey. So it's a very common format. And again, wherever I see func, to me that is a big, big flashing sign that says, put your Lambda expressions here. So hopefully this has kind of removed some of the mystery around Lambda expressions. Again, it took me a while to grasp them. Once I got them and my brain became comfortable reading them, I'm like, wow, this is really useful. And of course, when I go online and look at code samples, boy, those are a lot easier to read than they used to be. So that's what I have for you this afternoon. If you have any questions, I'll be hanging around after the conference. And again, you can head to my website, jeremybytes.com, and there's links for this particular talk. We can get the slides, code samples. There's also a YouTube series on this. So there's a screencast that you can look at, as well as, like I mentioned, some additional materials for delegates and extension methods. And if you have any questions, feel free to shoot me an email later, jeremy@jeremybytes.com. If you have a question, you're probably not the only one, and these turn into really good blog articles for me. So again, thank you very much for hanging out with me. And if you have any questions, I'll be glad to answer them after the talk. Thank you.